In this video, we'll be talking about instruction set architectures or ISAs and how they can be virtualized. So what is an instruction set architecture? It's a specification of instructions and native commands supported by a processor architecture. What you see on screen now is the x86 instruction set architecture with the different kinds of instructions and how they're laid out. There are multiple examples of ISAs. Intel x86 is by far one of the most popular ISAs for personal computers. In mobile PCs, ARM is quite popular. And then there are other architectures that are popular in niche areas such as MIPS, PowerPC, and SPARC. Now let's talk about ISA rings. Not all instructions are equal in an ISA. Certain instructions can execute only in certain domains of execution. And these are also known as the protection rings. The x86 ISA executes instructions in 4 separate rings. There's ring 0, 1, 2, and 3. Ring 0 is the most privileged and is reserved for use by the OS kernel, also known as the system mode. Ring 3 is the least privileged and is also used by applications. This is known as the user mode. Now let's look at the type of instructions that can exist in an ISA. There are two main types. There are privileged and non-privileged instructions. Privileged instructions are the instructions that have to switch control to ring 0 if they run in any other ring. This is kind of a problem for hypervisors and VMMs. If a guest operating system runs in user mode and then issues a privileged instruction, then how can that be handled? So let's continue looking at some of these privileged instructions. There are sensitive instructions. Now these are instructions that interact directly with the hardware. Sensitive instructions can be control sensitive, and these instructions change the state of the hardware, or they could be behavior sensitive. That is, the effect of the instruction depends on the hardware state. Note that all privileged instructions may not be sensitive and vice versa. And this is an important point that we will use in a few slides. So how do you handle sensitive instructions? Sensitive instructions depend on the hardware state and therefore must be handled by a hypervisor if a guest OS issues them. All other instructions are deemed as innocuous. So these include privileged instructions that are not sensitive. So there is a theorem that is alluded from Popek and Goldberg about the construction of a hypervisor. The theorem states that all sensitive instructions in an ISA must be the subset of the privileged instructions for the construction of a hypervisor. Now, most ISAs don't have this property. There are instructions that are sensitive but do not need to be executed in privileged modes and vice versa. Hypervisors can still be constructed, but they won't be true or efficient hypervisors. So, just to visualize that fact, this is what a true or efficient hypervisor would look like. All of the sensitive instructions are a subset of the privileged instructions in this ISA. And hence, it's quite easy to construct a hypervisor since the hypervisor runs in system mode and can handle all of these sensitive instructions if they are issued by a guest that is running in user mode. However, most ISAs look like this. They are not true or efficient in terms of construction of a hypervisor because there are sensitive instructions that are both privileged and non-privileged. So let's just take a quick look at how these instructions are handled by the hypervisor. Remember again that the hypervisor runs in the system mode. So if you have a privileged instruction that runs in the guest OS, it'll trap to the hypervisor for handling. And this is a visualization of how that occurs. When an instruction trap occurs, it is sent to a dispatcher that determines the type of instruction. Now, if it is a privileged instruction that changes machine resources, then it needs to be handled by an allocator. However, if it is an instruction that does not change machine resources, but it requires access to privileged resources, then it can be handled by interpreter routines.